So let's talk about threat vectors and attack surfaces. So threat actors need attack surfaces, whereby attack surfaces refer to systems with vulnerabilities in order to gain access. So threat actors need attack surfaces in order to gain access to our system. So they exploit these surfaces using threat vectors. We are going to cover threat vectors and attack surfaces in more detail in the next slide. Security professionals aim to reduce attack surfaces through effective security measures and risk mitigation strategies. So let's look at all this in further detail through these slides. Let's first see the differences between attack surfaces and threat vectors. So in cybersecurity, attack surfaces and threat vectors are interconnected concepts critical to understanding security vulnerabilities. So what are attack surfaces? So this refers to the total sum of points or areas where unauthorized users can attempt to enter or extract data from the environment or organization or our system. So attack surfaces refers to the points through which unauthorized users can gain access to our environment. That's what attack surfaces means. And examples can be hardware devices like our computers, network interfaces, API endpoints, user interfaces, and through third-party services. Then threat vectors refers to the specific paths or methods attackers use to exploit the vulnerabilities in attack surfaces. So the threat vectors are the methods used to exploit attack surfaces, whereby that can be phishing emails, malware distribution, social engineering, use of unpatched software, and stolen credentials. Those are threat vectors that can be used to exploit attack surfaces. So security professionals work to minimize attack surfaces while monitoring and blocking common threat vectors. As attack surfaces expand, e.g. through cloud adoption and Internet of Things devices, new threat vectors emerge, requiring continuous security adaptation. So let's look at some common threat vectors like message-based threat vectors. Through these threat vectors, we can have email attacks. This is where we can have phishing and spam that are common entry points. So here, phishing and spam, these messages can be sent through email to all members of the organization, and the attackers need only one member or the credentials of only one member or employee of the organization to have access to the system. Hence, attackers only need one success to accomplish their goal. So they send out multiple phishing emails with hope that only one employee can be trapped by the phishing email for them to succeed in the attack. We can also text messages and instant messaging can also carry out similar threats as email, and the same can happen through voice calls, and that is referred as vishing, whereby vishing is the use of voice calls to trick users through phone conversation to provide sensitive information. So the next, we can look at network and system-based threat vectors. So when we look at wired networks, some attackers may actually be bold enough to physically enter the facilities to access unsecured network jacks, which gives them access to our network and system. So any device an attacker can touch should be considered compromised. If an attacker can have access to an open port within our organization, and which gives him access to our network, we should consider that that port is compromised. Then when we look at wireless networks, these are the easiest and the most commonly used threat vectors and attack surfaces. Attackers can access networks from parking lots without physical entry. If someone can access the organization Wi-Fi through the parking lot, then they would not even need to enter the organization. And sometimes even Bluetooth devices without security settings are vulnerable to connections to malicious attackers. Then we can also have system-based or our own system as an attack surface and the threat vectors aiming for our system. So this can occur through poorly configured systems with open ports or default credentials being used. So if our system is configured with many open ports, that's already an attack surface. Yeah? An attack surface, because someone can easily access these open ports due to the vulnerability that is in the configuration of our system. And also, legacy applications may contain unpatched vulnerabilities that can actually no longer be patched because it's no longer being released, or new updates are no longer being released by the service provider of the application. So that also poses a significant risk. We can also look at file-based attack vectors, where files are used in order to go through our system. So this can be done through malicious files, where files are embedded with code to trick users into activating the malware. So it will look like a normal PDF or a normal file, but encoded with code. So in case it's opened, it activates the malware. It can also be done through infected images, where the images contain hidden malicious code, and these can be delivered through email, via email, file servers, or any other accessible locations, but usually through email. These images or files can be sent, tempting the email user to open the file and activate the malware. Another way they are distributed is through removable media, where, an example, a USB drive can be left in a public area, and this is meant to lure curious users who are also up for a free USB to put it into their computer system, giving access to the malicious attacker to that computer system the moment the USB drive is opened. So those are file-based attack vectors. And then we also have supply chain attacks. Now, supply chain attacks, this is where the attacker is actually very sophisticated, that they can attack your system before it even reaches your premises. This is where, for example, they can attack your ICT infrastructure from your suppliers, where they can tamper with the devices. For example, if they are hardware providers, attackers may tamper with the devices during manufacturing or shipping of the devices before they reach your premises. And during these attacks, attackers can open up backdoors for themselves, in that when they reach your system, when the hardware products reach your premises, the attacker already has a backdoor and can access your system. Supply chain attacks can also be carried out through software providers. This is done in a way that vulnerabilities are inserted before the release or through update mechanisms. So before the release of a software, a vulnerability can be inserted by your attacker, and this will give them a channel into your system before you even purchase the software. It can also be done through third-party service providers, and these offer indirect attack paths. So third-party service providers or suppliers offer an indirect attack path. As we have seen in case of hardware products, it can be tampered with while still being manufactured or during shipping. Software providers, vulnerabilities can be inserted before the release of the software product and before its delivery. So this gives an indirect attack path to the attacker into your system. So the problem with these supply chain attacks, they're actually one of the hardest to detect, as backdoors are installed before even the customer has a chance to get their hands on their product. Thank you.